can there be a generic way to have templates that I can create easily as a developer without having to write code, and then have some unified tooling to consume those templates? And I'll talk more about Mason in a bit, but basically at a high level, Mason currently consists of these 4 packages, and they're all Dart packages on pub.dev. So the top left one is just the core Mason package, which is just the templating engine. And you can use that standalone in a project if you're building your own CLI, for example. We have the Mason logger, which is just a reusable logger that Mason CLI ends up using. Mason API to manage remote bricks, which we'll talk about in a bit. And then the one that we'll talk mostly about in this presentation is the Mason CLI package, which is the one-stop shop command line app for managing your templates. So we'll take a deep dive into Mason CLI. At a high level, it's just your friend when it comes to creating and consuming reusable templates called bricks. As I mentioned, it's written in Dart, but the templates don't have to be written in Dart. You can template anything, any language. And right now, the templates are powered by Mustache, which we'll take a closer look at. And Mason wasn't built in a vacuum. It was heavily inspired by existing tools like Stagehand from the Dart ecosystem. Maybe some of you know Stagehand. It kind of got folded into the Dart CLI tooling. Yeoman from the JavaScript ecosystem, Cookie Cutter from Python. Maybe some of these are familiar. And so I kind of want to quickly just look at how can you get started with Mason really, really easily. And then we'll dive into some of the more advanced topics. So the easiest way to get started with Mason is to just install it from pub.dev. So Dart pub global activate Mason CLI. Disclaimer, you need Dart on your machine before doing this. But if you also prefer using Homebrew, you can use Homebrew for those out there who prefer that. Just one thing to note is on Homebrew, it's named Mason, and on pub.dev, it's Mason CLI. So that's confusing to some people. So just keep that in mind. And once you've installed Mason, know that everything went well if you can just type Mason in your command line and see something like this. So you'll see a nice little usage description. And a bunch of commands that you can use, which we'll kind of cover throughout the rest of this talk. And so kind of the next thing that you might want to do when you install Mason is just initialize it in an existing workspace. And there's this command Mason init. Maybe if you're familiar with NPM, there's NPM init, and other CLI tools have similar init commands. And pretty much all that does is it just generates one file called a mason.yaml file. And all that really means is we now have a file in our current directory that allows us to register 0 or more templates. And those templates can be used within this directory or any subdirectories. So anytime you use the Mason CLI, it's going to scan from where you're currently running it upward until it finds the nearest mason.yaml file. And then it'll execute all the commands based on whatever file it finds. So if you run Mason init, let's say we're in this Mason playground, we'll see something similar to this output. And again, like I mentioned, it's just one mason.yaml file that's generated. And if we take a closer look at that file, it comes with one pre-installed template called hello, and it's versioned. So 0.1.0, build number 1. And you can see some comments in here. Like, for example, you can do Mason make, which we'll take a look at in a second. But one thing to note is you can also install bricks from other sources. So this versioned one is coming from a remote registry. But templates can also come from Git URLs or local paths, just like in pub.dev when you can register your dependencies and have overrides, or even like the dependency itself can come from maybe your current directory. And so we've initialized Mason. So the next thing to do is, similar to pub.get, Mason has a mason get command. So you can run mason get, and that will basically look up all the bricks that are in your mason.yaml file, install them locally, cache them, and then generate a lock file for you so that your teammates, if you're using this on a team, will be guaranteed to use the same versions of all the templates that you have. Because you can also use semantic versioning for the version templates. So you can put a caret in front, et cetera, or provide a range of versions. One thing to note is it also generates this .mason directory, which you should git ignore if you're using Mason, because that just tells Mason on your local file system, this is where all the cached bricks are. So you don't want to commit that because it's not going to make sense for your teammates. So just keep that in mind. So if we run mason get, like I mentioned, we're just generating a lock file, and Mason is installing and caching the bricks on your machine. And you can verify that this worked by just doing a Mason list or a Mason ls for short, and that will just output all the installed templates that you have on your machine. By default, this is going to be scoped templates. We'll talk about global templates later. But yeah, Mason ls will kind of just give you a list of all the available bricks, what versions they are, and where they're coming from. So in the case of this example where we just initialized Mason from scratch, we have one brick called hello. It's version 0.10, build number 1, and it's coming from this thing called registry.brickhub.dev. But we'll talk more about that. Don't worry too much about that. And again, I just want to reiterate, if you were to leave this workspace, like let's say I were to change directories into Dart Playground instead of Mason Playground, and I were to run Mason ls again, my bricks are gone because those were all scoped to that directory. So everything that we've done so far is scoped. And that's really handy for example, if you have templates that are specific to a single project, like maybe you have a TypeScript project that has a bunch of templates that are TypeScript specific and a Dart one that has Dart templates, and you want those scoped, this is the use case for that. And lastly, the thing that probably everyone's curious about is how do you actually generate code? So we've installed the template. We have this hello brick on our machine, and we can use the Mason make command. And that will just look up the metadata for the brick, prompt for any variables that template requires, and then it'll just generate the code in the output directory. So if we run Mason make hello, this one brick happens to have one variable that it requires of type string called name. So it'll prompt me, hey, what's your name? I can either use the default value in this case, which is dash, or I can provide my own. So I'll say my name's Felix. And then if I hit enter, I'll get one file generated, which is hello.md. And the contents of that will just be hello Felix with a little hand wave emoji. So you've generated at this point code from an existing template. One thing to note is you're not limited to just being prompted for variables. So you can also specify command line args for those variables. For example, if you're running this in CI environment and you already know ahead of time the variables that the template needs, you don't have to resort to the prompting. You can specify -- name Felix, run Mason make again, and it will just generate the identical output. In this case, it's telling me it's identical down below because there are no changes. And similarly, if you have a really complex template, maybe you have like a template for generating a project and you accept flavors, you accept bundle IDs, you accept all kinds of things. In those cases, it's probably easier to have like a config file where you list all these variables, and then you can pass the config file to Mason via the -c flag. So exact same output in this case, but we're just passing it a JSON configuration. I mentioned earlier you can specify the output directory. So by default, things are generated in the directory in which you run Mason, but you can also specify -o followed by the output directory, and everything will be generated in that desired output directory. The relevant files in folders will be generated as needed if they don't already exist by Mason. So in this case, we have a new file inside of out/hello.md. And if we're to go back to the original directory that we were in and rerun Mason, and this time instead of using Felix, use dash, we'll notice a conflict occurs because there's a file already named hello.md. The contents are different from what the newly generated contents would be. And so at that point, Mason will prompt you, hey, do you want to overwrite this file? Because there's already an existing file. And if we just say lowercase y, we'll tell Mason to overwrite just that one file. So it'll go from saying hello Felix to hello dash. But you don't have to just say lowercase yes. You can say uppercase or lowercase y. You can say uppercase y to overwrite all files. You can say no to skip that file, and you'll continue getting prompted for future conflicts. Or you can say A to append, so you can append the newly generated output to the existing file. And there's also an ability to specify the conflict resolution strategy directly as a command line arg. So you can say on conflict. By default, it's prompt, but you can also specify overwrite, skip, or append. So you have some control over how to handle file conflicts when using Mason. Another cool thing that was somewhat newly introduced was detecting changes. So if you're running this in CI, maybe as like a validation step to make sure no one forgot to generate code, you can specify the -- set exit if changed. And that will tell Mason, hey, run this, and then if there's any diff, as in like a developer forgot to run this on their local machine before committing those changes, then fail with a non-zero exit code. So this is a really helpful check in your CI, for example, if you want to verify that code was generated before being committed. And that's all really there is to getting started with Mason. So we've taken a look at how to install Mason. We've taken a look at how to initialize Mason, how to fetch dependencies, or how to fetch bricks, and how to generate code from a brick. And really, the Mason get command I just included here for educational purposes, but init automatically fetches the template. So it's really 3 commands to get started with Mason: install, init, and then make. And now I think the next thing that you're probably all wondering is, OK, now that I understand how this thing works, how can I create my own templates? So I want to cover a little bit about how to create a template, what is a template really, and then some kind of like closer look at syntax of generating templates, and then this thing called hooks, which we'll get into. So you'll probably notice a theme in this talk. Everything is a command. So we have a command for generating a new template. And fun fact, that uses Mason to generate a template within Mason. So Mason uses itself. And so Mason basically just generates a brand new brick for you. And it generates a couple files. Generates a README, a license, a changelog, which are probably things that you're all familiar with. And I won't spend too much time talking about. But it also generates a brick.yaml and then this __brick__ folder. And so this is Mason new in action. So if I say I want to create a brick named example in my current directory, I should see something like this. And we have a new brick. And so I won't worry, like I mentioned, about all these docs files that you're probably all familiar with. I'll focus on the two on the right. So this __ brick template folder is basically where all your templated files are going to live. So anything that you have in that directory, and you can have files, directories, more subdirectories, files within those subdirectories. It can be like a full Flutter project, for example, in that directory. That's going to be mirrored when you run Mason make, whatever is in that directory. So it's like your magical folder of what's going to get generated when someone runs Mason make with your template. And the Mason or the brick.yaml file is kind of like your pub spec for your brick. So it'll contain metadata about the brick, like the name, description, version, what variables it requires. And a closer look at the brick.yaml, it should look really familiar to your pubspec.yaml. So name, description, version are all the same. Even environment, instead of a Dart SDK, you can specify what version of Mason your template requires. Maybe you're using some newer features and your template needs at least a minimum version of Mason to work. And then vars, so a template doesn't even need to have variables. It can have no variables if it's a static template. But you can also have as many variables as you want. And the main thing that's required is the name of the variable and then the type. So the available types currently are string, number, boolean, enum, and array. And string and number are pretty boring. We've kind of seen what those look like. But I want to cover what boolean, array, and enum will look like. So let's say you have a project and you want to give the user the option if they want to add dependabot to their project. That's just a yes or no question. So you can have a variable that's dependabot with type boolean. And the prompt will get used by Mason when someone runs Mason make if they're prompted. The description will get used when someone runs Mason make -- help or -h. And then you can have a default value. So by default, it will be false. In this case, we're overriding the default value. And so with this setup, if someone runs Mason make, they'll see, do you want to add dependabot? The Y is capital since that's the default. And that's all there is to it. Slightly more complex is the variable type of array. So a common thing is having flavors in applications, maybe, especially if it's a mobile app. And maybe you have a variable that prompts the user for what flavors you want the app to support. So you can, again, specify description and a prompt. But variables of type array have defaults. So in this case, maybe you always want to default to having a development and production flavor. And then you can specify the total set of values that a user can select from. And so when they run Mason make, in this case, they'll have a nice kind of experience where they can use arrow keys to select values and spacebar to select and deselect. So they can pick either none, some, or all of those options. And then you have access to that in your template. And enum is very similar, except for the user is forced to pick always one option from the ones that you've provided. So a good example, this is taken straight from a template that's already available, generating a license. So if you have to pick a license, you have these available options. You have to choose always exactly one. And that's really all there is to the brick.yaml. The __ brick folder, like I mentioned, is just any files, any directories, and those will get mirrored when you run Mason make. And those things can have mustache in them. So the files can be templated, the contents of the file names can be templated, and the contents of the files can be templated. So in this case, we have a README, we have a lib folder with some file named mustache brackets name.dart, and then a pubspec.yaml. And if we were to run Mason make and pass the variable name FlutterVikings 2022 as the name, we would see on the right-hand side the exact same structure, except for rather than the mustache syntax, we now have FlutterVikings 2022.dart. And the same thing applies to the contents of the file, so not just the file names, and also directories as well. So putting it all together, this is probably like the most important slide for seeing how everything works. We have our brick on the left. We have just a simple hello.md in the example that we saw at the beginning. That brick.yaml just has one variable, what's your name? And then the contents of the hello.md are just hello with mustache brackets. And then from the user's perspective, generating code from this template, they just say Mason make hello, Mason prompts for the variables, and then it generates the file according to what's in the __ brick folder. So that's kind of like a full look at the simplest example end to end from what the brick actually looks like to the user experience of generating the code. And we kind of now covered most of the hard stuff. And really, I kind of want to just dive into a couple of different things that you can do with the templating syntax. So Disclaimer, I'm not going to cover everything that you can do with Mustache. You can check out the Mustache spec. It's the second link on this slide. But the first link is the package that's being used by Mason to actually render everything using Mustache. And I just want to give a shout out to the developers maintaining it. And so the first part of templating that might be interesting is if you want to conditionally render things in your template. So a good example is maybe you're rendering some sort of Flutter or Dart package, and you have a pubspec.yaml, and you maybe want to give the user the option to say, I do want to publish this on pub.dev or not. So in that case, this line, publish to none, you will conditionally include. If the user says, I want to publish, you don't want to include it. And if the user says, I don't want to publish, you want to include it. So it's that inverse case. And so for those cases, you can use the Mustache syntax with this caret, and that will negate the condition that's being evaluated and then render the contents. So if publish is false, publish to none will be rendered. And if publish is true, this will not be rendered. And the inverse of that, let's say you want to give the option to specify whether they want to use Google fonts or not. You can just use the exact same syntax, except for instead of a caret, you use the hashtag. And that will render if the variable is true and not render if the variable is false. So in this example, publish is false and use Google fonts is true. So we get the pub spec on the right. You can also use loops in your templates. So let's say you have an array of platforms, and maybe you're using that for just generating the platforms that the Flutter app supports out of the box. And maybe you have a README that lists, hey, this app supports these platforms based on the user's preference. You can use this, a very similar syntax. So the variable name preceded by the hashtag and then a closing tag. You'll notice with Mustache, there's always a closing for every opening. And then you can use the dot to basically access the current value in the array. So in this case, platforms is an array of strings, and you can use dot to access each item as you iterate through. And so with this Mustache code on the left and these variables on the bottom, we should see a README that looks something like this with iOS followed by Android followed by web. Probably the most useful thing are these things called Lambdas, which are basically just functions that manipulate the output that's going to be rendered. And Mason comes with a bunch of built-in Lambdas. So in this example, we have a widget, a stateless widget class. And so you can see the snake case lambda is being applied to the variable named name. And we have the Pascal case lambda that's applied to the class name. Because we always want our files to be snake case, and we always want our classes to be Pascal case. So if we were to generate this, basically if we were to use Mason make with this template and provide the name Viking ship, notice that Viking ship is all lowercase with a space in between. It would generate a file, Viking_ship, and then the class name would be Pascal case Viking ship, just like you would expect with a Dart or Flutter class. So I mentioned there are a lot of built-in Lambdas. I'm not going to read you all of these. They're all on the docs online. But there's tons. Constant case, camel case, Pascal case, even Mustache case. So there's a lot in here, and you can refer to the docs later on. Oh, actually, one other thing on this slide. I mentioned that every opening tag has a closing tag in Mustache. And Lambdas have this shorthand syntax, which you saw in the previous slide. So you can either use the shorthand syntax or the full syntax. Either one works. But the shorthand is really handy for file names, because otherwise you'll have trailing slashes in your file names, and that gets really crazy and confusing. So the last concept I want to talk about for templating syntax are these things called partials, which you can think of as just nested templates. So a good example is, like, think about maybe the files that you generate. You always want to have a common copyright header maybe at the top of the file. And you don't want to repeat that in every single file, because that would be really hard to maintain and redundant. So you can create a partial, which is just any file in your __ brick folder that has this tilde in the front. That's what denotes partials. And these files will not get generated when someone runs Mason make. Instead, you can reference them in existing templates. So I can reference like copyright.md here instead of header.md. And that template will be kind of inserted into my output wherever I need. And I only have to maintain that in one place. Basically, I don't have to keep repeating myself over and over and over again. And you can have as many partials as you want. So in this case, we have a header and a footer. So we covered all the basics of generating a new brick, what a brick looks like, the syntax of a template. Now I'll cover a little bit about hooks, which are a really powerful feature that I actually think a lot of people maybe don't know about or haven't used or maybe scared of. So hopefully we'll try to demystify what these hooks are and make it a little bit more friendly. So you can play around with them if you're curious. And the easiest way to describe hooks is just a way to execute code either right before or right after code is generated. So think about if you had the ability to write your own custom code that had access to all the variables, could mutate variables, could do whatever you want to do, either right before or right after Mason does its code generation step. And that's what hooks are. And the easiest way to get started with hooks is just create a new brick and then specify -- hooks. And you'll see all the previous output that we saw in addition to this hooks folder that has a pub spec, a pre-gen, and a post-gen.dart. So the pub spec is just your normal pub spec. Just by default has a dependency on Mason because you need the dependency on Mason. You can add other dependencies here too. Like your hooks can depend on other packages. So if you have common logic that all of your hooks rely on, you can have that as a dependency in your hooks. And really the key thing to note is a hook is just one function called run that takes a hook context. And hook context comes from package Mason. And so using that context, you can read variables. So in this case, we're reading the value of name. It's just a map of key values. We can access the Mason logger instance. So you have the same power that the Mason CLI has at your fingertips. You can programmatically prompt for things, alert the user, show progress, do whatever you need to do. And then you can also create new variables, mutate the values of existing variables. So think about a case where maybe you statically analyze someone's current file system, and then you generate the variables for them. So they never actually type any variables into their command line. You've done all that for them. You can do that using hooks. And a post-gen hook is the exact same thing. The only difference is when it's run. So pre-gen right before code gen, post-gen right after code gen. And a good thing or a common thing that you might do is do some cleanup, formatting, install dependencies for the user. So in this case, we're running Flutter packages get for the user right after the template was generated. And this is an example of an async hook, but the previous one we had a synchronous one. So you can do async code in a hook, no problem. And we're using the progress API from the Mason logger package here. So you can show progress message with a little loading indicator for the user, run some process, and then complete the progress. I'm not handling errors in this snippet. So in this case, if an error happens running Flutter packages get, that'll get bubbled all the way up to the Mason CLI and surface to the user. And the user will still see the error, but it's less pretty than if you were to actually handle the error yourself and maybe give some custom error messaging. So keep that in mind. You probably still want to have error handling in your hooks code. But that's really all there is to creating a brick. So at this point, we've initialized Mason. We've taken it for a spin quickly, and then we've looked at how to create a custom template. So next, I'll talk about not state management, but we'll talk about brick management, because we have to talk about managing something. And I want to start by introducing this thing called BrickHub.dev, which you can think of as just a registry that's completely free for anyone to publish any templates and for the community to use. So anyone can head over to BrickHub.dev. If you have Mason installed on your machine, you can search through any existing templates that are published and use them right away. So BrickHub just lets you install, discover, and publish templates for free. So you can think of it as like pub.dev pretty much, but just specific to bricks. And currently we have over 100 bricks published from various authors, over 53,000 downloads. We have templates ranging from creating a Flame game to starting off with Firebase and Flutter, to starting off with Amplify and Flutter, to creating a macOS UI app. So GitHub Actions we talked about. So there's tons and tons of bricks already up online, and they're all like, getting lots of usage. Like for example, this feature brick has 4,000 downloads. The model one is actually the most popular one for generating a just Dart model with to JSON from JSON, copy with, etc. So yeah, BrickHub.dev is a great place if you have a brick that you don't have just like an internal dependency for your team, and it's something that's more general and can be used by the community. You can publish for free, and other people can use it. And the easiest way to publish is just to go to BrickHub.dev, request access. It's still in an alpha stage, but you should get an email invite within like 24 hours, sign up, and then you can log in via the Mason CLI. And just like with Dart and publishing packages to pub.dev, you can just do Mason publish. It will by default publish whatever's in your current directory, but you can also pass it a path to a custom directory. And then you'll get prompted, are you sure? Because once you've published something, you can't undo. So just keep that in mind. For anyone depending on your template, it would be bad if you were to publish it and then just be able to remove it later. So yeah, definitely make sure that you're publishing something that you're comfortable publishing. And then if you're on a machine and you want to log out and wipe your credentials from the machine, you can just do a Mason logout. So that's all there really is to publishing. And now that we kind of look at how you can share bricks with the community and how you can publish things, you might be thinking like, okay, how do I start adding things from BrickHub to my project? And the first part is like, how do I find what I even want? Like, how can I find what I'm looking for? So we saw BrickHub briefly in those screenshots has a search capability. So you can just search online for whatever bricks you want. But you can also use the Mason CLI to search directly from your terminal. So you can just do Mason search and a full text search on the metadata for all the published bricks sorted by popularity. And again, it's pretty much identical to what you'd see if you use the web interface. So let's say I'm looking for widget book. I want to add widget book to my app. I can just do Mason search widget book, and I'll see 2 results right now, a starter template as well as a widget book app. And then I can pick which one I want. And when I'm ready to add a template, I can add from various sources like I hinted at earlier. So the simplest way to add a template is from a local path. So this is a case of maybe you're working on a team. Actually, no, you're not working on a team. You're working alone, and you have a template that you don't really want to share with anyone, and you're only going to use on your machine for that one project. You can just create that template locally and then do Mason add. And add always requires the name of the brick, and then followed by, in this case, a path. And what that will do is Mason will find that brick, install it, and then update your mason.yaml to have that reference for you. This is exactly the same as if you were to find your mason.yaml, open it, add this entry, and then run Mason get. It's the exact same thing, but Mason will do that for you. And like I mentioned earlier, you can install from Git as well. So I can install a widget template from the Mason repo, and I can specify the -- git URL to give it the URL of the repo. And if the brick is not at the root of the URL, I can also specify the Git path. So in this case, the brick is not at the root of the repo. It's in this bricks/widget folder. You can also specify a git ref if you want to pass a commit or a tag. That's also exactly like you would expect with pub.dev. And again, it'll install that brick and then update the mason.yaml. And lastly, the simplest way is if you find what you like on BrickHub, you can just say Mason add the name of the brick. That will find the newest version on BrickHub, resolve it, and then update your mason.yaml. And as I mentioned, everything is using semantic versioning, so it'll use the caret to kind of specify within this non-breaking range of versions, I'll always get the newest one. And the lock file will help you lock it down to just whatever version you're using for your team. One thing I didn't note is you can do a Mason upgrade. So if you have a lock file, you've installed some templates, you can run Mason upgrade, and then that will upgrade to the most recent versions of those templates and update your lock file. So now that we've installed 3 different bricks from 3 different sources, we can verify by doing Mason ls again. And in this case, we'll see we installed Amplify Starter. That's coming from BrickHub. We installed the example template that we made on our machine. And then we installed the widget template from GitHub. So we can see the 3 different sources. And again, if I leave my workspace, they're all gone. If I do a Mason ls, it's empty. And so you might be thinking, hey, Felix, that's pretty annoying. Like, what if I want to use widget anywhere on my machine? I don't want to keep initializing Mason in every single workspace. And so for that, you can just install a template globally by adding the -g flag. So exact same commands as before, just tack on a -g or a -- global. And those templates will be installed globally on your machine, and you can use them from anywhere on your computer. So in this case, if I reinstall all these globally, and then I leave my workspace and go to this other playground, Mason ls will still show me empty, but if I list my global bricks that are cached in whatever directory, this is different depending on the OS that you're running on, but if I list them globally, I'll see the bricks that I have available. So you can just use Mason make from anywhere, and those globally available ones will work. And then if you find a brick that you tested and maybe you're not happy with and you want to remove it, just use the remove command and add the -g if you want to remove it globally. And that's all there really is to it. So we've taken a look at how to add and remove. One thing I want to touch on is it's still really early stage, but there is some IDE integration for VS Code. So you can install the VS Code extension currently and initialize Mason in your current directory, add and remove templates. My favorite, which is just right-click to make, so you don't have to be in the command line. And also another fun thing is if you're modifying a Mason YAML file, any changes will automatically run a get for you, so you'll always have the most up-to-date dependencies without having to run Mason get manually. This is similar to the Dart extension when you save your pubspec.yaml. And what this looks like is I can use the Mason add global brick. In this case, I'll install the hello brick from BrickHub. And then I can right-click anywhere. It's a bit small, but I'm right-clicking and clicking make, and then selecting hello from the dropdown, and then entering the name. And then it's going to run Mason make for me, and then generate the hello.md hello FlutterVikings. And that's in the directory that I've right-clicked on. So if I had subdirectories and I right-clicked on some nested directory, the output would be generated wherever I selected. And so that's brick management. And so now if we go back to our original story with the teammate joining the team and picking up a new feature, now they can use Mason make, or they can right-click and make from VS Code. IntelliJ coming soon, and they can generate a new feature. In this case, this is literally a brick that's available on BrickHub, so I can say Mason make feature underscore brick. It asks some other things that I've omitted, like what state management do you want to use, and some other questions. But for brevity's sake, I've excluded those. And then you can hit enter once you answer all the questions, and then bam, we got all the files generated for our feature with our structure in less than a second. And then we can go in, modify the logic, open a PR, and then everyone's happy because we're all on the same page about what best practices are. And there's no confusion about what's legacy and what's new. And so to recap, Mason will allow us to consistently generate code that's custom for our team in a quick, efficient way. And then we can reuse templates that we want with the community by publishing them either on GitHub or BrickHub or anywhere else. And I want to show a little bit of bonus content since we have some time. So I kind of teased on this earlier that the core package that has the just rendering and templating engine, the Mason package, you can use in your own tooling. And so this is a little snippet of how you can actually do that. So if you just write a main.dart file and add Mason as a dependency, you can create a brick, and there's a bunch of named constructors for path or git or version. Give it the name and version in this case, since we're using the version name constructor. And then you can create a generator from that brick, and then give it a target and the values of the variables, and then you can generate programmatically without the CLI. So you can write your own CLIs really easily and use the Mason logger to prompt for whatever you want and give a completely custom experience while still leveraging the rendering and templating capabilities of Mason, which is really nice. And this is actually what very good CLI does for those of you who have used it. It's just using Mason and bricks under the hood, and it's just doing some custom prompting on top and some logic on top of everything and kind of stitching things together for you. But behind the scenes, it's just using Mason. And that you'll pretty much find that exact snippet in the code base if you look at GitHub. And some other notable mentions, Umbra, which is great for when you're using shaders in Flutter. That's powered by Mason, and Dartfrog CLI is also using Mason. And they're all using it in the exact same way that I showed in that previous snippet. So there's a lot of cool things that you can do, both in terms of improving your efficiency, but also building tooling on top of the existing tools. I just quickly want to touch on roadmap. So some things that we're currently working on or thinking about how to do even is the first one, multiple templating engine support. So it'd be really nice if you weren't limited to just Mustache. And if you can specify in your template, hey, I want to use Jinja, or I want to use Handlebars, or I want to use some other flavor of templating engine. So that's something that's currently being thought about and discussed, how that could be supported in an efficient way. Template extensions is another one. So it would be really nice if we could have like a base Flutter template maybe, and then specify that my template extends that base template. So I don't have to always manage the iOS, Android, web directories, all that stuff. I can just worry about the Dart code that's actually changing and have the base template just handle the core platform code, for example. Multiple publishers. So right now, if you publish a brick on BrickHub, you're the only one who can publish updates to it. So we're working on adding the ability to add multiple publishers, so you can add your teammates and everyone can publish updates. And then I mentioned this, right now VS Code has support, but IntelliJ doesn't. So IntelliJ plugin support, hopefully, with feature parity for what I just showed on the VS Code extension side. And that's all I've got. So thank you so much. We made it.